When we're planning a landscape installation, it's hard to know how much water we'd save or how much money we'd save if we designed a little differently. The Landscape Water Savings Calculator answers these questions. Calculating your water landscape savings takes 3 simple steps. Step 1 is to measure the total landscape area. The total landscape area is any area that you're going to develop or redevelop that will absorb water when it's done. That might be proposed lawn or plantings or proposed mulch areas even without plants. It could also include pervious paving or pervious decks where the water soaks through to the ground underneath. Do include the boulevard, at least the parts of the boulevard that are absorbent. That's because the property owners are expected to maintain the boulevard in front of their land, and you may need some water to maintain it. Don't include areas that won't absorb water. Things like buildings, unless they have a green roof on top. Or certainly don't include impervious driveways or walks or impervious patios. Once you have the number, put the total landscape area in square meters into the spreadsheet. Step 2 in calculating your water savings is to divide that total landscape area into different zones or areas of landscape treatments. Divide your landscape design into areas that have similar water needs. These are called hydrozones, and there can be hydrozones with no water needs or low, medium, or high water needs. As you look down the calculator, you'll see a range of choices in landscape type or treatment. As you go down the list, each has a greater water need than the one above, including unwatered areas near the top, watered planting beds of various types, and mown lawn areas, which are the highest use. Special landscape areas would include vegetable gardens, or park sports fields, or lawns around playgrounds. These are special areas that justify higher water use because of their needs. In the spreadsheet, the base, or the worst case, would be if the landscape were 100% irrigated lawn. That would be the highest water use. We need to do much better than the base case to meet reasonable targets for water conservation. When you look at the worksheet, you can provide just option A, or there's space for up to 3 options to look at. So you can try different treatments, different mixes of treatments, and compare different designs. Let's look first just at option A, insert areas in square meters for our landscape treatments. Although you can measure out in the yard, it's also useful to sketch up a simple hydrozone diagram in plan view. This sketches out the areas of each landscape treatment. This is the hydrozone diagram for option A, and you can see the percentages in the pie chart. Option A has 50% mow and lawn. Shrub areas in this scheme are in 3 different hydrozones. High water shrubs in the front yard, low water shrubs in the side yard, and moderate water shrubs in the back. Together, these shrubs cover 40% of the total yard. A utility zone in the second side yard doesn't have plants, but it's a mulch surface. The third step using the spreadsheet is to calculate your savings. Before we consider other options, let's look at step 3 to see how option A compares with the base case. When you look down at the bottom of the program, the numbers are calculated for you. As well as restating the total landscape area, the calculator provides a landscape maximum water budget. This budget is the amount of irrigation water that's needed to replace water that evaporates or transpires through the leaves of plants. The amount of the budget varies with the landscape area, and it's based on the local climate. So there'll be a different budget in Kelowna than there is on the coast. Applying more water to your yard than this budget is wasteful. The calculator uses the landscape areas you've entered in the different types to estimate your landscape water use. in cubic meters per year. The base case, which would be 100% irrigated lawn, exceeds the landscape water budget by 236 cubic meters a year. As you use the calculator, you'll find that the percentages are telling. For instance, it's difficult to reach water conservation targets with more than 50% irrigated lawn. The first step towards meeting water conservation targets is to reduce the mown and irrigated lawn area in your scheme. By having 50% lawn, option A beats the water budget by 35 cubic meters. Comparing option A to that base case also shows that you would save 271 cubic meters in a year by having shrub areas with corresponding irrigating hydrozones instead of all mown grass. That savings is equivalent to 3 typical backyard swimming pools full of water. The bottom line of the calculator shows potential dollar savings. These savings are based on water pricing from leading communities in British Columbia. The numbers show what you would potentially save compared to the base case of 100% irrigated lawn. Now let's compare option B and C. Option B on the spreadsheet just barely meets the water budget. It demonstrates the solution with no shrub areas and as much grass as possible. It has 65%. To make this amount of grass work, it's necessary to have at least 27% in non-watered landscape area. This is achieved by areas of mulch without plants, by permeable spaced wood deck, and by pervious paving on the patios. This scheme also has a vegetable garden, which is classed as a special landscape area. These special areas are allowed more water budget by the formulas due to their important function. Now let's look at option C. It's a good example of water conservation. It exceeds the water budget by 75% and saves over 7 swimming pools of water a year compared to the base case of 100% irrigated lawn. To do this, option C has 36% unwatered areas, combining 27% in pervious decks or mulch or paving and sand play areas, and 9% in a naturalized area. Option C has only 17% lawn in the backyard, and it has 3% in a vegetable garden. The front and side yards use shrub and ground cover as lawn substitutes. Option C also looks carefully at how shrub areas are irrigated. It uses a drip system for small or narrow shrub areas, and it has high efficiency sprays on the larger landscape zones. The irrigation system is designed to have different irrigation timer zones for each planting or lawn hydrozone. As well as saving water, this solution saves substantial money every year. So although more expensive to install, the result is a higher quality yard with higher resale value that eventually will pay for itself.